Hello everyone, welcome to my channel. In this series, we are learning DSA concept wise. So let's understand today's problem. Problem statement is that we have given two arrays, array 1 and array 2 of size n and m respectively, and an element k. The task is we need to find the element that would be at the kth position of the final sorted array. So let's understand this with an example. Let's take example array 1 with elements 1, 3, 4, 7, 8 or 10, and array 2 with elements 2, 6, 11, 12 or 14. And if we create another array with these two arrays, array 1 and array 2, and that is also a sorted array. So that array will look like this array will look like 1, 2, 3, 4, 6, 7, 8, 10, 11, and 14. Suppose k is 5. So we need to find the kth position of the final sorted array. So the fifth element in this sorted array would be 1, 2, 3, 4, 5, 6. This 6 will be the fifth and kth element. So we need to find this kth element in the final sorted array. So first let's understand the brute force solution. As we have given two arrays, array 1 and array 2. So the first solution that comes in our mind, like we created another array and then we find the kth element. So we can take another array like this and we can insert all the elements of first array in that, then the all the elements of array 2. First let's insert all the elements of first array. We can insert all the elements of array 2. Now we can sort this array. So this array will, after sorting, this array will look like this. And now we can get element at index k minus 1 position. So our answer will be this. So first let's understand, if we go with this brute force solution, how our code will look like. So first, like we have given two arrays, array 1 and array 2. This is of size n, this is of size m. We will create a new array, final array of size n plus m. So now we will run one loop over first array up to n elements, and we will insert all the elements of array 1 into final array. Same, we will iterate over array 2 with of m size. Then we will again iterate over this and insert. And now we will sort our final array, and our answer will be final array of index k minus 1. So here if we see, we used one loop over first array. So the time complexity of this will be big of n. Here it will be big of m. And here we sorted the array of this final array is of size n plus m. So this will be n plus m log n plus m. So we can say that our time complexity will be big of n plus m plus n plus m of logarithmic n plus m. This is the time complexity. And the space complexity of this problem is we use this final array of size big of n plus m. So that space complexity is we are using n plus m. Now let's understand the optimal solution. Here we will use two-pointer approach to get the kth element. So let's understand how the two-pointer approach will work here. We will keep one pointer, let's say I, at the starting position of array 1 and one pointer, let's say j, at the starting position of array 2. Now we will run a loop for k times, and in each iteration we will compare the elements of ith position and jth position. We'll store the mean of element present at I position and element present at j position, and we will keep updating the value. So in this way, during the kth iteration, we will get kth element of the final sorted array. Let's understand this in depth by solving this problem. As we will run a loop for k times, so let's take a variable count that we will use to count the number of iterations. So initially, let's take it 1. So as initially I is at 0th index of array 1 and j is at 0th index of array 2. So during the first iteration, we will compare 1 and 2 and we will store the mean value of these two elements. So for now, mean is 1, and we will increase the pointer of the lower element. So here we will increase j by 1. Now we will increase the count also because it's the time of second iteration. Now during the second iteration, we are comparing 2 and 3. So as 2 is lesser than 3, first we will update the value of mean and we will increase the I. Now during the third iteration, we will compare 4 and 3, as 3 is lesser than 4. So we will update the value of mean with 3 and we will increase the j. And now it's fourth iteration. So during the fourth iteration, we have 4 at ith position and 5 at jth position. As 4 is lesser than 5, we will first update mean and then we will increase I. Now it is the fifth iteration and we will compare 8 and 5, and as 5 is lesser than 8, so we will update mean with 5 and we will increase j. So as count has been reached to 5, so we will break the loop and we will get our answer in the form of mean. So now let's code this problem, then we will get more clarity. So here we have given array 1, array 2 and n and m are the sizes of array 1 and array 2 respectively, and we need to find the kth element of the final sorted array. So as we discussed that we will use two pointer approach. So let's take two pointers I and j. As we are seeing that we need to return the answer as a long. So let's take the answer in long. Now we will iterate for k times. So let's take count is equal to 1 and count should be less than equal to k and count plus plus. Here, if I is less than n and j is less than m, then we will update answer like this. If array 1 of I is less than array 2 of j, then the value of answer will be array of I, or it will be array 2 of j. And here we increase the pointer. If I is greater than n, or maybe j could be greater than m, so we will handle like that. If I is less than n, then we will get answer like this. Else, if j is less than m, then answer will be array of 2 j plus plus, and we will return our answer. Let's see. Now let's submit the solution. So now let's understand the time complexity and space complexity. So here, as we are seeing that we are using only one for loop, so the time complexity will be big of n plus m, because case value could be n plus m. And as we are not using any extra space, so the space complexity will be constant, big of 1.